In today's video, we are going to deep dive into the concept of simple linear regression. In my previous video, I have explained the difference between a simple linear regression and a multiple linear regression. When we have a single explanatory variable, we call it a simple linear regression, and when we have multiple explanatory variables, we call it multiple linear regression. In this video, we are going to understand the different parameters in simple linear regression using an example. What is that example? Each one of us have come across advertisements on television. Now, think about the companies which are putting out these advertisements. These companies are incurring a huge cost on these advertisements. And depending upon the advertisements, consumers like you and me purchase their products. So if you are working for such an organization, always there would arise a question of whether the expenditure that you make on these advertisements, are they actually getting converted into sales? You would be asked to find out the relationship between your advertising expenditures and your sales of your product. This problem can be solved by the simple linear regression. And if you have different channels through which you are advertising your product, then you can use a multiple linear regression to find out the effectiveness of an advertising expenditure on different medium. Now, using this as our background, we are going to step into the world of simple linear regression. Now, what exactly is the goal of simple linear regression? So basically, our goal is to predict one variable based on another variable. So we want to predict the sales of our company based on what? Based on the advertising expenditures that we make on televisions, radio, newspapers, social media, so on and so forth. Over here, since we are dealing with simple linear regression, let us rest our case to television advertisements. This can be generalized to different topics. You can find the relationship between price and demand of a product, the relationship between gold price and dollar, the relationship between price of house and the locality, the relationship between the price of car and the size of car, and so on and so forth. A number of examples are infinite where we can establish a relationship between different variables. So if we are establishing a relationship, it is something in terms of y and x. So y is a function of x. Over here, we have already learned that our y is nothing but our dependent variable. That is, it is the explained variable or the predicted variable. And our x is nothing but our independent variable, explanatory variable or the predictor variable. Now here comes our example. Over here we have expenditure on TV and the sales. So when $230 are spent on TV, sales increase by 22.1 lakh. When $44 are incurred in television, sales increase by 10 lakhs. When $17 are incurred on television advertising, sales increased by 9.3 lakhs and so on and so forth. By just looking at this over here, we understand that there is some positive relationship between TV and sales. So when your expenditure on TV advertisement increases, your sales also start shooting up. So our scatter plot looks something like this. What is a scatter plot? A scatter plot is nothing but a relationship between x and y. So the plot is nothing but the relationship between TV and sales. So on the y-axis you have TV, that is your independent variable, because now over here we want to find the impact of TV advertisements on sales. And on your y-axis is nothing but your sales, because you're trying to predict your sales. And I have plotted these points that you see over here. Now, the easiest way to find out a relationship is a linear relationship. All of the relationships are a bit complicated, but it is very easy to understand a linear relationship intuitively as well as mathematically. So what is our idea over here? To fit a line. What kind of line do we have to fit? We have to fit a line which passes through all the points. So we want to fit a line which looks something like this. So what is our goal? To fit a line which passes through all the points. Now, if there is a line, there is an equation of line. In our school, we have studied that the equation of line is nothing but y is equals to mx plus c. So over there, m was nothing but your slope, c was your intercept. Over here, we just changed the terminology. We just write that y is equals to a plus bx plus epsilon. Now, you all would be wondering what exactly is this epsilon? Epsilon is also known as your residual, or it is known as your noise term, it is known as error term, so on and so forth. What exactly is this epsilon? Can you see the orange line? The orange line is nothing but your predicted line. Now you have certain values on the predicted line, and the black dots that you see over here, they are your actual values. So the difference between the orange line and the black dots is nothing but your epsilon. So how will we rephrase it into statistical terms? The difference between actual values, the black dots, and the predicted value which lie on the orange line is your epsilon. Now let us understand A and B. So our A is nothing but our intercept and our B is nothing but our slope. Now what is A? The point where it touches the y-axis, it is your intercept. So over here, can you see where this orange line touches the black line? That is your intercept. That is the point A. Now what is slope? Slope is nothing but the measure of its steepness. Now, if you see, our epsilon is nothing but y minus a minus b of x. Over here, the best possible solution is when all the points lie on the line. In that scenario, our epsilon is nothing but 0. But it is not a real life scenario where all our points would lie on the predicted line. So our aim is to minimize the distance between the actual values and predicted value. And once we hear about minimization, what clicks into our mind is differentiation. So after applying a few differentiation techniques, we come up with the formula for A and B. Now let us deep dive into these residuals and residual sum of squares. Okay, what is residual sum of squares? It is the difference between the ith observed response and the ith response value predicted by our model. Same as in our previous example where it is the difference between the actual values and predicted values. Initially, we were only dealing with one point, but in our data, we have hundreds of points in our data. So we have epsilon 1, epsilon 2, epsilon 3 up to epsilon 100. So our RSS is nothing but epsilon 1 square plus epsilon 2 square plus epsilon 3 square up to epsilon n square. Now remember, why is the need of squared in this? Why can't we just take an addition of all our error terms? There is a chance or a possibility that these error terms may cancel each other out. Sometimes error terms lie above the line and sometimes error terms lie below the line. So in some cases it is positive, in some cases it is negative. There is high chance that these error terms may delete each other or they may cancel each other, and at the end we may get a zero as summation of all our error terms, which is not a good indicator because there are a lot of errors in our data. Why will we approximate it to zero when in actuality there are a lot of error terms in our data. Hence, we use the idea of using the squared. When you square it, everything will have its own weight and nothing will cancel each other out, and we will get our error terms squared. So our RSS, we are substituting the value of epsilon 1 as y1 minus a minus b1 x1 and y2 minus a minus b1 x2 the whole square plus yn minus a minus b1 xn the whole square. After a lot of calculus and differentiation, we come up with the formula of b as b is nothing but summation of xi minus x bar yi minus y bar. So our x bar is nothing but mean of x and y bar is nothing but mean of y divided by sum of xi minus x bar the whole square. This can also be said as covariance of xy upon variance of x squared. And the value of a is nothing but y bar, which is nothing but the mean of y, minus b, we have found the value of b, into x bar. So a lot of calculus goes behind the formula. So in our future videos, we will be understanding the differentiation which goes behind these formulas. I hope everyone is clear with the idea of the different parameters in simple linear regression, the residual sum of square, and the estimation of the parameters of simple linear regression. Thank you.